Hello guys, so this is the part 1 of the playlist DSA Conquered. So in this we will be going to talk about prefix sum particularly, and if you have not seen the trailer of this playlist, go check that out because that is very useful of what this playlist is going to be about. So the first topic we will be going to talk about is prefix sum particularly. So if I talk about arrays, the main topics of arrays particularly lies in prefix sum, sliding window. These are the two main topics of arrays I have just have a look on. So these patterns are the most important according to me. So for this, firstly we are starting with prefix sum, and if you are watching this video, make sure you are subscribing it because each subscriber is making my day, right? You just have to click the red button to make my day and say a thank you because I have today bought seven patterns of prefix sum by which you can master prefix sum. Definitely I have tried this on my own, and I have seen the results that now I can conquer any prefix sum problem, easy level, medium level, and maybe a hard level as well. So let's dive into the video. Yeah, so this is the prefix sum patterns I have made in my video. Let me do the mic little bit far away from me. So these are the prefix sum patterns. So firstly, before going to the patterns, let us firstly analyze what is prefix sum actually. So if I talk about prefix sum, so the first thing that come to our mind is what is a prefix sum. So you might have heard in the stats that you find the mode by cumulative frequency, right? So prefix sum is similar, that is it is cumulative sum. Right, now what is cumulative sum? If I give you this example, so if for this array, if I need to find the cumulative sum, it would be 2, then 2 plus 3 is 5, 5 plus 5 is 10, 10 plus 8 is 18, 18 plus 9 is 27. So this will be the cumulative sum for this particular array, right? Secondly, what else we do is it is valid for both positive and negative numbers. So there is no restriction for whether the number is positive in the array or negative in the array. I am telling this because sliding window has a restriction that the number should always be positive for applying the sliding window problem. Apart from that, yeah, this is particularly the prefix sum. If I give you a particular example, here is an array like 2, 3, 5, 8, 9, and we need to find the range sum. So what is a range sum? If I tell you that you need to find sum from index 0 to 2, you can say, so, or you can say 1, 2, 3, right? So from here to here you need to find the sum of the indices. What will you do in this situation? The very simple option, you will say, Kunal, you can just go from here, run a for loop, and that's the answer. But in the later stages, it is right now a very good answer, but in the later stages I will this is a very simpler explanation of what prefix sum is, right? You can definitely solve it by a simple for loop, but if I talk about a very let me explain you what's the difference of between a simple for loop or this prefix sum. By this prefix sum, you can definitely extract the answer in big O of n. And if I talk about the for loop, you can extract the answer in big O of n. Every time you have to run big O of n, but in prefix sum, you just need to traverse once and you will get the answer in big O of n, right? So how to do this? It's very simple. Just find this cumulative sum array, right? If we need to find the sum between index 1 to index 3, that is particularly this. So as you can definitely see, you need to find the sum from here to here. So you already know that the sum, so what this particular index mean is sum from index 0 to index 1. What does this mean? Sum from index 0 to 3. So what particular index in the prefix sum array states is the sum from 0 to that particular index is this one, right? So you need to find the sum from here to here. It is that simple. So you already know that the sum from here to here is already 18, right? You just need to subtract the sum from here to here. That is, you just if I give you a formula, the formula would be prefix sum of r minus, if I raise this down, prefix sum of l minus 1. Simple. It is 18 and it is 2. So answers come out to be 16, and this is in big O of 1 only. So main formula you have used is this one. This is the main formula, right? So this is basically prefix sum. And if now we can just jump out into the pattern 1 of prefix sum. So what sort of problems you will be finding in prefix sum is, this is the first pattern. So pattern 1 particularly says that you will be solving a question using prefix sum plus hash map, right? So pattern states that if any particular question says that you have to find out subarray sum that is exactly equal to k, subarray sum that is exactly equal to k, not less than k, not greater than k, exactly equal to k. For an example, here is the question. This question states that subarray sum equals to k. Definitely there are more type of question you can find out. Definitely I can link them down in my GitHub, give the link of my GitHub in the description box, definitely. So what this question states that we have an array 1 2 3 and we need to find out how many arrays or how many sub arrays particularly give the sum k equal to 3. We need to find that out, right? So sub array basically are contiguous, right? Someone will be saying that we can apply DP here, but DP is a very vast solution, and DP particularly we apply where we need subset sum, right? Because subset are non-contiguous, sub array are contiguous. That is why we are applying prefix sum here, right? So if we want to solve this problem, definitely we can solve that. And let me tell you the templates of all the question we will be solving, right? So as you know that I have already told you that we will be using prefix sum plus hash map. So we need to initialize a hash map so this is the hash map, and in the hash map we will be storing two things. We can make a particular node, right? We will be storing two things. First is sum and second is index. So sum till this particular index is that is what we will be storing, and we will be initializing it with 0, -1. This means in the initial part the sum of the array is 0, definitely. And we can initialize a variable sum in the outer of the for loop, and we can just now run a for loop. So if we have array 1 2 and 3 here, k is equal to 3. So what will we be doing? We will start with 1. We will start with 1. If we are starting with 1, we have sum equal to 0 plus 1, that is 1. So sum we have is 1. Now we need to search in the hash map. What do we need to search and what do we need to put in hash map? That is pretty much simple. We need to, every time, I can write it here, every time just push sum into the hash map and find for sum minus k into the hash map. That is what we need to do. Insert sum and find sum minus k. Simple, right? Pretty much simple. And if we are finding number of subarrays, not the length of the subarray, so we can definitely do this 1. We don't need to do -1 here. Do it 1, because it means that the sum of the subarray count is 1. We have one subarray which has the count 0, right? That is an empty subarray, right? So sum has become 1. What we need to search is sum minus k. So we need to search in the hash map 1 minus 3, that is -2. That is not available. So just do a simple thing. just put sum is right now 1. Just put 1 in the sub array, and 1 is not present. That is why we will be doing just this thing. The sum of the sub array equal to 1 is appearing once. That is what it means. Now what we need to do? We need to move to the next index. Next index is 2. Sorry, next element is 2. Now sum becomes 1 plus 2, that is 3. Right? Now we need to search. What do we need to search? So sum has become 3. We need to search 3 minus 3. Here we need to have k. Okay. So 3 minus 3 is 0. We need to search for 0 in the hash map. Do we have a 0? Yes, we have. And what's the count? This is count, right? Count is 1. So answer पहले 0 था, now it had become 1. Simple. Because we have found this. Right? Now what do we need to do is sum equal to 3. We have sum equal to 3. So 3 comma 1 we have stored here. Right? Now in the third step we have 3. Now sum has become sum equal to 3 plus 3, that is 6. What do we need to find in the hash map? 6 minus 3, that is 3. Do we have a 3 in the hash map? Yes, we have. And what's the count? 1. So plus 1 we will be doing. That becomes 2. So we have done all the iterations and 2 is the answer. Simple as I can't speak the word. So this is pretty much simple, right? You understand all this thing. If you have any doubt, you can definitely reach me out in the comment section. That is open for you. I will also put some questions related to this in the description box, so go check them out. So main thing we have came to know is we have to store sum and we have to retrieve sum minus k. And this count, whether we need to have the longest subarray or whether we need to have the count, it just depends on the question. Right now we have to find the count, that is why we found the count. And you will be wondering that it would be always 1. No bro, if we will be having negative numbers here, you will get to know that we can have multiple iterations of multiple numbers. That is the thing, right? Now let us move to the pattern 2. If we come across the pattern 2, this is the same pattern, exactly the same pattern, right? What this pattern says as subarray sum exactly sum equal to k, but this time the question will be asking divisible by k, remainder, multiple. This type of question the question will be asking, right? So this is exactly similar, but the change would be what do we put in the hash map and what do we retrieve from the hash map. And this time it would be same, that is store and retrieve sum modulo k from the hash map. That is it, and the question will be solved definitely. So if we solve this question right here, we have 4 5 and then we have 4 5 0 minus 2 0 minus 2 minus 3 and 1. This is the array, and we need to find out how many subarrays are divisible by k equal to 5. Simple. First of all, we have to initialize a hash map. Definitely we have initialized it. Now what we need to do is start with initializing. Start with the initializing part. So we will initialize it with 0 comma 1. We have initialized it with 0 comma 1. What does it say? Remainder comma count. As we are storing the remainder only, right? So initially we had the remainder 0 and the count of the remainders 0 is 1, right? Now let us start one by one simply. In the case of 4, we need to have sum as well, right? Starting mein sum will be 0. So 4, if we have 4, so sum becomes 4 and sum modulo 5 becomes, or you can say definitely just write it 4 modulo k for easy things, and it becomes 4. So do we have a 4 in the hash map? No, we don't. No, we don't. So just store 4 comma, what do we need to find? Number. Yeah, so we are doing right. So 4 comma 1 simply. Next index is 5. So sum becomes 9. 9 modulo 5. What is 9 modulo 5? It's 4. Do we have a 4? Do we have a 4? Yes, we have. Yes, we have. So the answer becomes 1 right now. We found here. Now what do we need to store? We need to store. We need to store here. Now you will be understanding why I told you that these count would be changing, right? That was a different use case, but here you can see we already have a 4 in the hash map, so we can just increase the count to 2, right? Now if I go 0, now sum becomes 9 again, and again we can say 9 modulo 5 is 4. Do we have a 4? We have 2 4s. We have 2 4s. So answer becomes 3. So till here we have found 3 such subarrays which will be divisible by k. Let me tell you how. This is the first array, this is the second array, and this is the third one, right? So this is particularly working, right? If I go on for one more iteration, let's say we have -2. Now sum will become 7. 7 modulo 5 is 2. Do we have a 2? No, we don't. So store 2 comma 1 simply, and this will be going on, right? You will definitely find the answer then. I don't want to waste your time in these steps. I think you got my point, right? Also, I will be putting the questions of all these patterns in the description box, so you can just check this out. So this is the main thing right here. This is the main thing. Store and retrieve. Definitely. So if I talk about the importance of patterns, so if I talk about importance, so this is the most important one, the pattern number 1. Second is not that important. Third one is the most important one. Prefix sum plus sliding window. So if we go right here, when do we use prefix sum plus sliding window? The pattern or the things you have to look for is subarray sum will now not be equal to k. In the earlier stages it was definitely equal to k. Now it will be either greater than k or either less than k. Second thing, I told you that if sliding window is coming, only positive numbers can be used in the array. Second pattern. Third, it will be definitely asking you for maximum length subarray or minimum length subarray. That are the 3 patterns you need to look for. And if we solve this example, what this question particularly is saying is minimum size subarray sum. We need to find, this is the array we have, this is the target we have. We need to find the minimum length of the subarray having this number of target, and target whose sum is greater than or equal to the target. So we need to find greater than or equal to the target, right? So let's solve this particular example. We have 2, 3, 1, 2, 4 and 3. For sliding window we have to initialize 2 variables, that is right and left. We have 2 variables right here, right? We will go step by step. No issues, no worries with that, right? So firstly we will be having sum. What else we want in this? We will be having a sum. We will be having length. Then we will be having minimum length. For now let's work on these only, and we can definitely go with L and R, right? So if right now our L and R are at 0 index, this is 0, 1, 2, 3, 5. L and R at 0 index. So what is the sum? Sum becomes 2. Or then we need to check. Is sum greater than equal to k? No, it is not. So definitely we have to increase the numbers. So right will move to the next position. Now left it at 0, but right will be at 1, right? Now what will be the sum? Plus 3, that will be 5. is 5 greater than equal to 7? Is 5 greater than equal to 7? No. Again we need to move the right. So move to the right. Now add 1. 6. Is 6 greater than equal to 7? No, brother. Again move to the right. Is 8. So next is 2 elements. So 6 plus 2 is 8. Is 8 greater than equal to 2, brother? Yes. Now 8 is greater than equal to 2. So what's the length of this subarray particularly if I talk about? First subarray we have found. What's the length of this? Tell me. 1, 2, 3, 4. So length is 4. Now minimum length is also 4 because we don't have any other option right now. Right? So if we have found sum, now we have found that sum is greater than equal to k. Now we need to move L because anyhow we need the minimum length. So we need to decrease, right? So now we will be moving L to the first position. R will stay here and here per we have satisfied the condition here, right? Now what will happen is we have moved L here. So we need to decrease it by 2 because this is now done, right? So it will again become 6. Is 6 greater than equal to k? No, my brother. So minimum length will be 4, but it doesn't have any length, right? So what do we need to do now? Again move R, that is 3. Wait a second, yeah, I did a mistake here. It will be 3 here and it will be 4 here, sorry. Yeah. So now we will move to the fourth index. Fourth index is 4, so sum becomes 10. And is it greater than equal to k? Yes, it is. But what's the length of this? Again 4. Again the length is 4. So its length is 4, minimum length it will be 4 as well. Now if we move to the next index, that is final, now it's greater than equal to k. So we need to again decrease the length. So now just increase it to 2, increase it to 4, and we need to subtract 3 now. So it will become 7. Now is it greater than equal to k? Yes, it is. So what's its length? 3. So now minimum length will also become 3. Are you getting my point, brother? Yeah. As you know that it is greater than equal to k. Now we need to decrease the length again. So now it will become 3 and 4. Now we have to decrease this as well. So minus 2 if we do, that is 5, right? So we will get 5, but 5 is not greater than or equal to k. So we need to increase R. So 5, 3. Now what it does is add 3, 8. Now it is greater than or equal to k. Now increase increase L. 4, 5. So we need to just delete 2 out. 6. Here it will be 9. It will be 7. So finally we have 2 and 2. Minimum length, the answer we get is 2. So this is the it. You can definitely find the code in my description box. We don't need to go. If you are getting what is the pattern and how to solve it, you can definitely write the code on your own, right? So let's move to the next particular pattern. I will put more questions for this pattern in the description box. Now rest 3-4 patterns are very rare to come in the exams, but we definitely need to do it, right? Next pattern is range difference array. So how to recognize this pattern? First thing is range update. It will be saying you increment or decrement the values from index number 0 to index number 5 for an example. So how to solve? For an example, we have this is the nums array and it is saying from index 1 to index 3 increase each number by 2. So you will say, Kunal, this is a very lame question, right? You can definitely solve it out in having a for loop, right? We can solve this by for loop, but we have even a good use case of prefix sum here. So if I talk about this particular question, let's go 0 0 0 0 0. We have 5 times, right? Yeah, 5 times we have 0, and firstly it's saying to update 1 3 2. means this is the left, this is the right, and this is the value. From index 1 to index 3, increase each number by 2. That is what it is saying, right? So how to solve it? So how prefix sum can be applied here is, you can have a look, right? If we are increasing each number by 2, so it becomes, definitely it will become 2, it will become 2, it will become 2. Aren't you seeing a pattern? So if we only add 2 here, if we only add 2 here, if we only add 2 here, and at the end of solving the question we apply prefix sum, don't you think this 2 would be added to all the numbers after this? It will be added, right? So that is the institution, or that is the thing we need to keep in mind. But you will be wondering, Kunal, we have added 2 from here to here, but it will be added to this element as well. Right, my brother, you have thought a very good point. So that is why we will be doing -2 here, simple, each time. This is pretty simple, right? Now let's solve this question using prefix sum, right? Let's solve this. It's pretty easy, bro. 0 0 0 0 0, right? From index 1. So what do you need to do? Simply index 1 add 2, and index r plus 1, that is this one, index r plus 1 subtract 2. That is it. Second we need to do is 2 4 3. Index 2 add 3, index 5 is not there, so don't do anything. And third is 0 2 -2, index 0 add -2, index 2 add 2, opposite sign, right? Now just add all these elements. You will get -2 here, you will get 2 here, you will get 5 here, 0 and -2. Now find the prefix sum simply. So this is -2, this will be 0, this will be 5, this will be 5 again, this will be 3. That's the answer. Simple. No, nothing in this, right? Now fifth pattern is 2D prefix sum. This is rare to come, but we have a question on LeetCode that find out the prefix sum in the 2D arrays. So what does prefix sum in the 2D array means is, if we want to find prefix sum of 1 comma 1, that is this index, what does this mean? All the sum of the elements before this thing, right? Sum of all the elements before 9. What this mean is, from 7 to 9, 5 and 4, sum of all the elements I want. This will come in the PS of 1 comma 1. How can we find this particular thing? We have a very simple formula. Just use, if we call this array, just do ARR of 1 comma 1 plus prefix sum of if I call this I comma j, simply let's call this I comma j, do I minus 1 comma j, then prefix sum of I comma j minus 1, then prefix sum of I minus 1 j minus 1. Simple. So all the sum of all the elements here we will be getting in this index. Isn't it simple, right? If we move to the next thing, that is prefix and XOR. So I have not used any example in this use case because this is a very basic point. We just need to find out the prefix sum for XOR. So as we were doing in the first and second patterns, we were doing for sum. Here we just need to do it for XOR. Last pattern is pretty much difficult, but it is rare to come as well. This is not as important as well. So let's solve it with a pretty basic example. We have to track the parity in this, right? And you will not come across this in the first attempt, but you need to solve it in a different, you have to think in a different manner. For an example, we have to find the length of longest substring containing vowels in even count. So first intuition that will be coming into your mind is just track all the elements, like the count of E is 1 here, the count of E is 2 here. So if we talk about this, so count of E is 2 and count of L is 1, so even count is 2, just display, it is valid. But the thing is, in this particular use case, the time complexity will increase massively. So what's the alternative? We will be using bitwise and prefix sum. For an example, if we start with E, so what we will be doing here, as you know that in English alphabet we have 5 vowels, so we will initialize all the vowels with 0. Simple. This represents A, this represents A, E, I, O and U, right? Now what we need to do, simply just traverse element one by one. If we have, supposedly we called it vector, we have a vector. Initially it will be 0 0 0 0 0. We will store it in the hash map 0 0 0 0 0. In this use case we have to find the longest substring, so that is why we will be using -1 here. This will represent index, this will represent vector, right? We start with E. We have the E as first element, so for E we need to do parity. For this we need to reverse this, right? For E it becomes 0 0 0 1 0, the vector becomes this. So we need to find out this particular index. Is this particular index occurring in the hash map? No. So just store it 0 0 0 1 0 at index 0. Then again we have index L. For index L we don't need to do anything because this is a consonant, so vector will remain the same. Do we have this vector in the hash map? Yes, we have at index 0. So what does the length becomes? We are right now at index 1, but this particular element occurs at the index 0, that is why length is 1. So store answer equal to 1. We have to store the maximum. Again we have 1. So what does it do? Reverse this 0 0 0. Now this becomes 0 again. So do we have this particular index in the hash map? Yes, we have, right? So the length becomes 2 and this index was present at -1, so length becomes 3. Is 3 greater than 1? Yes, it is, so replace it with 3. Then we again do it with E 0 0 0 1 0. Do we have this particular element in the hash map? Yes, we have at 0 index. So now the length becomes 3 minus 0, that is 3, but we already have a 3, so do not need to replace it. At the end we have T 0 0 0 1 0. It won't do anything because it is a consonant. Do we have this index? Yeah, we have at 0 index. So if we have that at a 0 index, just the length will become 4 minus 0, that is 4. So answer will be 4. That is it. So yeah guys, I hope it would have be a nice session for all of you guys, and I have covered all the patterns of prefix sum. But still, if you want to solve more problems, I have listed 7 questions for each pattern in my description box GitHub. You can definitely check them out and have some fun. And yeah, if you will be finding out the patterns I have told you, these questions will be just a piece of cake for you. You will be doing a cake on these questions. Yeah, that is it. And the next video we will be coming up with the next important pattern for array, that is sliding window. So stay tuned, subscribe to my channel and like this video if you want to see me happy.